All right, so now another question they do, they are going to ask you how many charges. They're going to ask you charges. How many charges were lost? I'll say charges lost. That means they want the answer in coulomb. Then another one, they're going to ask you how many electrons were lost. So they want the number in electrons or protons. It's about the same number, lost and gained. We good, ne? Good. Now they must be specific. So they must say how many charges were lost in B. Kapako A. Either one, the numbers is going to be the same, you'll see. Now, all you have to do, let's just say charges lost. Let's just put it here. I'll say charges lost. So it's going to be the final charges. I'm talking about charges, final charges, minus the initial, the one that you have in the beginning. Initial. Now, if you are looking at A, the final charge on A is positive 5, ne?
Yes.
The starting was positive
14.
Good. So that means you are going to say positive 5 minus positive 14, ne? Minus 14. It will give you the answer. But then, if I was doing that for the B, I want to show you the answer is going to be the same with different sign. For the B, the final was positive 5, then minus a negative 4. So the yellow one, you get a positive 9. Isn't it right?
Yes.
The other one, you get a negative 9. Can you see now? Now, watch now. Positive always refer to protons. A are positive, the B one, with positive 9. That means it became more positive. That means it gained the protons. Another way to say that, it lost the negative. The more hot it becomes, if it becomes hot, you are gaining the hotness, heat. Another way is to say what? You are losing the coldness. Is that right? If I give you more money, you are gaining the richness. You are losing what? The poorness. Ne? Yeah, it's the same thing. All right. So this one, because I use 5 as coulomb and 4 as coulomb, this is the answer for the charges as coulomb. So if they were to ask you for A, the white one, you give them the negative 9 coulomb, right? If they ask you for the B, you give them a positive 9 coulomb. This is the gain and the loss. Now, if they want to know how many electrons were lost, these numbers say that 9, because any one of them, it doesn't matter. That 9 coulomb, it represents the lost or the gained. It's either one, it doesn't matter. But as a coulomb, I get final minus initial, ne? Then I can change that coulomb to make it electrons, like how we did it here. You see? If they ask electron, yeah. It's because the question started with coulombs. So I can get all the answers as what? As coulombs. If I take the very answers, I use 1,6 times 10 to the power negative 9. The answers will be in electrons or protons. Can you see? It's like this 14 coulomb here. I could have changed it by 1,6 to make it how many electrons in the beginning. And also how many electrons. And also here, that 10 coulomb, I could have used 1,6 times 10 to the 9 to get how many electrons it is. And yeah, final electron, then I can work with electrons. You see that? All right, so now we know to get the number of electrons is charge divided by 1,6. Isn't it right? Yeah. So now, I'm going to say now, number of electrons, I'm going to put slash and say also proton. It's exactly the same thing. So we are going to take the 9, we divide it by 1,6, multiply by 10 to the negative 19 equals 2. Let's use our bzz. I believe we are getting a 5,625. Am I right, ne?
Yes.
Multiply by 10 or to the exponent of what? Of 19. Then it depends. If the question asks you how many electrons, then you can say electrons. If they say how many protons, you say protons. It's the same answer for protons and electron. Like I said, we use our beautiful calculator. Not beautiful. You must put the zzz. The zzz. Huh? You must zzz, because we're doing electrons, electric. It's bzz, bzz, beautiful. All right. So this part, it's over. We'll see you in the next video.